very thick because usually it has to be under 100 nanometer. And it cannot be supported in anything because the electron has to go through your material. So you can't support it in a substrate, in a glass slide or anything like that. It has to be self-supporting in order to go right through. That's why you need all these high energy electron beams to penetrate through your material. And then very popularly you would have scanning electron microscope. We have one of the best in the business to look at materials. So again, you would have similar thing. You would have the source, the electron source. You have the object. In this case, it doesn't go through, right? So you would have all the condenser and objective lens located in a single column, and then your detector is on the side, and you're sweeping your electron beam through your material, and then you look for secondary electron to come up in order to see your electron microscope. And you can see down to 1 nanometer sub-Angstrom resolution with the microscope, with state-of-the-art microscope that we have like this. Okay, so this is a walkthrough of microscopy, very quick. And the key thing that I want to point out here, this is important physics, so I wanted people to understand this graph. We may not need to know the detail of these tool, but we should know some basic principle. I hope that people learn from the course if you need to communicate with your group member about microscopy. So I hope you remember this plot, right? This is a plot of what happened when the electron beam hit a material. So hit a specimen or a surface, right? So in this case, I make the specimen very, very thin so that I can look at transmitted electron. So when you're looking at TEM, transmitted electron microscopy, the electron beam go right through, and you detect the electron through your material. So what are you seeing really? You are not really seeing surfaces, right? Because you're actually seeing column of material. Because the electron is interacting a column of material that you see, right? You're not really looking at the top layer, right? Because the electron beam has to penetrate through the entire freestanding film. So be careful when people are talking about TEM. Even though you see beautiful single atom, you see a lot of these little pictures, but you're really looking at column of atom that you see on this film. And then as you interact, you would have this primary beam interact, you would have different electron coming out. You have backscatter electron, you would have OJ electron, you have secondary electron. So you have secondary electron, backscatter electron, and this is the typical range of these electrons coming out. So for example, secondary electron, they come out within 10 nanometer of the surface. So if you're really not looking at, if you're looking at SEM, you're not really looking at the top layer, the first layer that exposed to your beam. You're really looking at 10 nanometer deep. So you have to be careful when people talk, when you look at an SEM image, right? This is why this product is so great, because we really point out how surface sensitive are these techniques. Now you detect something called OJ electron, and we'll discuss this OJ electron. They come out 1 to 3 nanometer. They are a lot more surface sensitive, right? They can only come out from material within the top 1 to 3 nanometer. And if you look at backscatter electron, they could be quite deep because they are high energy electron. They also could come out 1 to 3 micrometer, in fact, 1 to 3 micron. And you're looking at X-ray emission because the electron can excite your material and cause X-ray fluorescence. They are also looking at 3 to 5 micron. So this tells you the pro volume and the information carried by this particle that you detect, right? Photon, X-ray photon, OJ electron, secondary electron. The type of information coming, where this type of information coming from, they are not that sort of sensitive. Like if you are backscatter electron, they are deep, they are 1 micron. X-ray, 3 micron, right? So you have to be careful when you're talking to people, material and analytical people. You have to know what you're talking about. You have to know, this is known as the pole volume effect. So you really not measuring the surface, okay? So I apologize, I've taken a little bit too long today, so I will stop, what time we have? We'll stop now, and then I'll come back to try to wrap this up, and we'll talk about service structure on Thursday, on Thursday.